Hello and welcome to Learn Data. I'm Nilesh and today we'll continue learning pandas and we'll be talking about missing values. In this video, we'll specifically look at how to find missing values, the equality between NaNs and nuns, and then we'll look at how the pandas treats missing values as in date time. We'll also look at how to insert missing values in a series or a data frame. Moving on, we'll look at how to handle NaNs in when we are working with mathematical operators, such as when we are doing addition or taking a mean or taking a cumulative sum of the data. Finally, we'll look at how NaNs behave when we work with a group by. So let's get started in Jupyter Notebook. I've already created this notebook and imported two libraries, pandas and numpy, and I've created these two data frames. I tried to put them in the description of this video below so you don't have to copy it right now. So this data frame has two columns, and here I'm making another copy of that data frame that we'll be using later on. So let me just pull all those data frames here. So this is data frame dfa, and we have data frame dfb, which has three columns, and then we have the data frame df and df2. So df is this data frame which has the indices 11, 13, and then df2 is the data frame where it has the indices that are not in df1. So this goes from 11 to 13. This has 11, 12, and 13, and I'll explain that in a minute why we are using those. So if you want to create these data frames, this is the code you'll need. That's right here. Okay, so let's get started, and first what we'll do is we'll just walk through an overview of what is NA. So dot is NA, then we'll look at what is not NA, and then similarly we'll look at how these behave when we try to compare them together. So our series is, let's look at the pdf2 series, which is this one. Here if we were to check how many if there are NaNs in this particular column X, we would type df2 dot pd dot isna df2 x, and this will give us the boolean series back which tells if there are NaNs in there. So the index label 12 we have NaN, and therefore that is returned true here. Otherwise the index level 11, it's false because there it's not a NaN value, there is a 0 in there. So that's one command. The second command is using not NA, pd.NotNA df2 and x. So here as you can see it's exactly opposite of what is NA is. So if it's not NA, then this will return true. So in this case the index level 11 would have true versus this would be false, and that's what we have right here. Now similar to this, if we want to go ahead and add another column, so let's say if we type df2.x, and if we give this a value NaN, then what would happen is that entire column would become NaNs. Okay, so the entire column is converted to nans or NaNs. Now here I just want to mention one thing. If we compare, so let's say if we say none is equal to none, here we get a true value back. So those two are comparable. However, if we say that np.nan is that equal to np.nan, so we get a false. And this is very important to remember, because let's say for example if you have a data frame and you're trying to identify if there are NaNs in that particular data frame and substitute with some other value if it is. So if you put this condition, it's not going to return the value that you expect. For example, in here in df2, and if you say df2.x, we know that these are all NaNs, but now if you want to check if those values are NaN, and if you issue this command, then you get false. So that's just to keep in mind that while using NaN, we have to be careful that if we are trying to use it to extract NaN booleans, if they are present or not, then that's not going to work. Next, let's look at using a timestamp. So if we pull the df2, and in this data frame we can add a new column, let's say pd.timestamp, and we can give a date here as a string 2020, maybe today's date. And now if we look at df2, this now has an extra column dt which has the dates in there. Now what we can do is we can try to change the some of the values from this data frame to NaNs, and also we can see how it is treated for the date column. So let's go ahead and do that. df2.loc, if we say if we give the labels, let's say 11 and 12, and for these two index labels, so these two rows, for the column dt, if we want to change the values to np.nan, what we get is this. We get nat, which is not a time. We do not get a nan because that's a date variable. It's converted to not a time type of missing value in Pandas. So that's interesting. One important point I want to make here while using the loc and iloc, if let's say here if we had index, so let me show you one example. I'm digressing from the topic here, but this is very important. Let's say if we have a data frame pd.DataFrame, and here we have two columns, say x is 1 2 3, and then that's the only column we have. And if we were to add index here, so if you say index is equal to say 11 12 and 0, okay, that's the index for this data frame. Now if we run this data frame, this is what we have. Now if you were to pull the value at index 0 using iloc, what would you expect to get? If you put as index 0, we are going to get this value. So this is what I'm going to show you. iloc, and if you put 0, we get a value of 1. And the reason why we did not get a value of 0, which is 3, we got a value of 1, because iloc is purely positional, and the index labels that we have given here, those are considered as label, even though they are integers, those are labels. And therefore if we want to get the value of at this particular location where the label is 0, then we have to use the loc and not iloc. So if you put a value of loc, then we get the 3 that we would expect when using the loc. That's just a side note that I wanted to share here. So moving on, let's look at another example for missing values. Here we'll see how we can insert missing values. We've already seen one above where we created NaNs for a column. This is just in line with that. So x is equal to pd.series, and let's say we have 11 12 and 13 in there. Now in this particular series, let's print it. In this series, if we want to change the value at location 0 to NaN, we would type, it's similar to what we would do for other values. So x.iloc open square bracket 0 close square bracket, and here we type none. Now if you look at x, we have inserted the value, we have inserted NaN at index location 0. Similarly, we can also use if we had used NaN instead of none, it would still be converted to NaN, sorry, np.nan. So here it is treated as NaN, and none was also converted to NaN because this is a float, and the reason why it's considered as float because we added a null value, and so NaNs are considered float. So even if it's an integer value, integer series, it's automatically converted to a float, and that's why we have these NaNs here. Now let's go ahead and create another series, pd.series, and in this series we are going to keep characters. So this would be like object, non-numeric. And now if we were to add the same none and nans to this, let's see what we get. So y.loc 0, and here if we try to insert none, we get none as against what we got in the integer or numeric series. And here if we go ahead and insert NaN, then we get NaN. So that's the difference between inserting NaNs or nuns in numeric versus the character and data types. So if you have a series or a data frame that has numbers in them, if you put a NaN, it gets treated as float. Whereas if you have a characters, alphabets, then that object data type can consider non-separate and NaN. So the advantage here is that if you have a column that has nuns, and if you want to use the equal to Boolean operator to check for that condition, then you can easily find those nuns in there. Now moving on, let's look at calculations, such as we'll look at addition, mean, and cumulative sum. Now we have the data frame dfa, which is this, and we have the data frame dfb. Now we know that if we are going to add these numbers to numbers, so 1 and 1, there will be 2. But what happens in case of NaNs? So let's go ahead and add dfa plus dfb, and here we can see that if there is a NaN on both the sides, then it returns NaN. And here for the column Z, there is no corresponding column in dfa, therefore the entire column here is NaN because it's not able to determine what to do there. Now similarly we can calculate the mean. So dfa.mean, and let's look at, let's say axis is equal to 0. So here for dfa, which is this one, we got the mean for each of the columns x and y, and if we get the dfa here, we can see the NaNs are ignored. So 2 plus 3 is 5, divided by 2 is 2.5, and that's what we have here as the mean. So the mean excludes the NaNs right here. Similarly, if we were to skip or ignore NA, so let's say skip NA. If we say skip NA is equal to false, then if we say that is false, then if there are NaNs in that particular column, we get a NaN as an output. So nothing is calculated for that particular column. Now if we move on and look at cumulative sum, so if you say df.cumsum, now here again the NaNs are excluded, and here we get a cumulative sum. So 2 is what we get for 2, and then for instead of 3 we have 2 plus 3, and therefore we have 5. So all the 3 NaNs in the beginning are ignored. However, if we were to again use skip NA is equal to true, in that case what we get, skip NA is equal to false. In that case the entire column becomes NaN if there is even if there is a single NA in that particular column. So that's the use of skip NA there. Now let's look at another example. Here we'll create a series. A is equal to pd.series, and let's create 1, 2, and then create a NaN, let's say 4. So that's the series that we have, which has NaNs. Here again, if we were to take a cumulative sum, so if you do a cumulative sum, so we get 1, then 1 plus 1 3, and then 3 plus 4 7. So the cumulative sum is calculated and the NaN is kind of ignored there. But if we were to put skip NA is equal to false, in that case it calculates the value of cumulative sum only up to a point till it reaches the NaN. So 1 plus 2 3, after that there is a NaN, so it cannot continue to calculate the value of at this particular location 4, and therefore in the output we get a return value of NaN. Now if we are going to use product, so for products what happens is, let's say if we have a series pd.series np.nan, and here if we take the sum of this series we get a 0 back, and instead of sum if we were to take a product, the product will get 1. So let's say prod, and if we try to use the product then we get a 1 value. Finally, let's look at how we can use group by. Here let's say let's even consider data frame df2, and in this data frame if we were to do a group by using column z, which has true and false, so df2.groupby z, and let's say if you want to get the sum or mean of all the values in that particular column, so we get 1.5 for false, and the reason is because for the column z there are 2 false values, and these are the 2 values associated with those false values in column x. So we have 0 and 3, so 0 plus 3 is 3, divided by 2 is 1.5, and that's what the value we have here. So again here all the NaNs are ignored that are in this particular data frame in both column x and column z. That was it for this video. In next video we'll continue learning in more detail about other types of operators in case of missing values. Please like, share and subscribe. I'll see you all in the next video. Thank you.